Welcome everyone. We're looking at preliminary chemistry module 3, which is water. We'll be exploring the following dot point. It says construct lowest electron dot structures of water, ammonia and hydrogen sulfide to identify the distribution of electrons. Okay, so I'll begin by asking a very simple question. What are Lewis dot structures? You may recall from earlier work done in chemistry that Lewis dot structures are commonly used chemistry diagrams. They are very useful in chemistry because they show valency or outer shell electrons around atoms. For example, consider the following table. In this table, we're looking at the hydrogen atom. The hydrogen atom is in group 1. It has valency electrons of 1 because it's indicated by the group that it's in on the periodic table. And so the Lewis dot structure would look something like this. We'd write the element symbol, which is H, and put a dot around, somewhere around the atom. And that's the Lewis dot structure for hydrogen. Okay, so I've just put the table on a new slide here. I want to introduce another element, say oxygen. Oxygen is, if you look at the periodic table, it's in group 6. So that means it has 6 valency electrons, and so you'd write the element symbol O with 6 dots around it. 1, 2, 3, 4, 5 and 6. Okay, well, here are 2 more elements that I'll show you how to do the Lewis dot structure for. We've got nitrogen and sulfur. So nitrogen is in group, let's have a look, it's in group 5. So I write 5. It has therefore 5 valency electrons, and so I write N with 5 dots around it. Doesn't really matter where you put the dots as long as you have the correct number. And sulfur is like oxygen in group 6, so it has 6 valency electrons, and so I put 6 dots around sulfur. Okay, so far it's pretty simple when we have just single elements. Next we'll be looking at how these elements combine together and how electrons interact with one another when there's a chemical bond. Okay, so the other thing that Lewis dot structures help us with is they show us how valency electrons interact when atoms bond together. So I'll just write what I've done so far. So hydrogen has 1 electron, oxygen 6, nitrogen 5, and sulfur 6. Can you see that all 4 atoms are actually non-metals? Okay, which means that if these atoms bond together, they undergo something called covalent bonding. Covalent bonding. And covalent bonding involves the sharing of electrons. Sharing of electrons. Okay. More accurately, this is called molecular covalent bonding, as opposed to network covalent bonding. Okay, so I've just put this on a new slide. I want to now look at Lewis dot structures of molecules. So suppose I have a molecule of water, okay, which, as you all know, is H2O. How would I represent this in a Lewis dot structure? I would have to write each of the molecules, each of the atoms I mean. So I would write, for example, hydrogen and there's two of them, so I might write hydrogen here with a dot which represents the electrons for hydrogen, and I'll write another hydrogen here, and I can make a cross representing the electron for that particular hydrogen, and then I put an oxygen atom right there. Now if you know the law of bonding, each atom tries to have a full valency shell. So I'll just do the oxygens just here, the dots for that. Okay, so the oxygen has 6 electrons in its valency shell. It needs 2 to complete its valency shell, in other words, to have 8. So the hydrogen here shares its electrons with the oxygen, and so the oxygen has 7, and this hydrogen comes along and shares its electron with the oxygen, so it has, the oxygen then has 8. So there's this sharing that's happening between these, and in doing so the oxygen also shares one of its electrons with each of the hydrogens, so the hydrogens have 2 in their outer shell, completing their valency shell. And so that's a very simple Lewis dot structure. Okay, let's have a look at another molecule. How about ammonia? The molecular structure of ammonia is NH3. Okay, so I'll put N, as you know, has 5 electrons in its valency shell, and so it's needing a further 3 to complete its outer shell to make it 8. And the hydrogens, there's 3 of them, so I can put a hydrogen here, and 1 there. And so each of the hydrogens shares its one and only electron with the nitrogen. Okay, so the nitrogen now has the 3 that it needed, so it has a full valency shell of 8, which is what it wanted, and each of the hydrogens have a full valency shell of 2. Okay, hydrogen only needs 2 electrons in its valency shell to have a complete shell. And so that's a very simple, again, Lewis dot structure for ammonia. Okay, so let's look at hydrogen sulfide. Hydrogen sulfide has the following molecular structure, H2S. It's similar to water, so there's S in the middle instead of oxygen, and S, just like oxygen, has 6 valency electrons, and so there it is, there's 6. And now I'm going to put 2 hydrogens, each one sharing its electron, and so again we have a full valency shell. Can you see how the hydrogens have 2 just as they wanted? Oops. And this one as well. And the sulfur atom has 8 in its valency shell because it needed 2, and the 2 hydrogens shared each of their electrons with the sulfur. And so there you have it. You've got 3 molecules, water, ammonia, and hydrogen sulfide, and their corresponding Lewis dot structures.